Hey guys, today we're going to look at Apple's Automator app, which is a way to automate repetitive tasks. You can create a workflow with kind of a top-down approach that handles one task after another until it completes the entire workflow. Today we're going to look at using the dictation accessibility feature, which is where you can say words and can help you type. In this case, it's integrated into Automator, so we can actually issue commands by saying the command name. In this case, the job will be called check ports. Check ports runs I wrote a Python script that is a port scanner searching for higher range ports in the 10,000s, 20,000, 30,000, those higher numbers. And it will look for a open port running a bind shell, and then correlate that to a process ID, and then terminate that process ID, killing the bind shell. So a bind shell is often created when the attacker has access to a system. So either they send an email with a malicious executable, or they got the user to download a macro-enabled Word document. And so once the attacker has access, that initial foothold on a system, they will spawn these bind shells. So let's say they turn off their computer, come back in a couple days. Hopefully these bind shells are still open. Bind shell is like when you connect to google.com. That web server has a listening port of 80 that accepts incoming connections. And that's essentially what a bind shell does for an attacker. It allows the attacker to come back later, connect to that port, and then they have access to their target. So in this case, the scenario in the attack chain, let's say you're sitting in an environment, you see a open access point, open Wi-Fi network. Maybe it's named something like Starbucks. Maybe you're even remotely around Starbucks, so you connect to it. So what I did on the attacker end is the attacker is running a malicious network. It allows you to browse internet and browse different sites, but what's running in the background is a ARP spoofing attack and a DNS spoofing attack. Once the user, we're targeting, in this case, Starbucks, we're targeting a web developer, and a web developer may be searching for website themes. Most popular one is Bootstrap themes. So we're going to, in this DNS spoofing attack, I created a wildcard for any domain name that contains Bootstrap. So as the victim is browsing to different sites looking for themes, they're going to be redirected to the attacker-hosted Bootstrap site with a link to download a DMG. Once that DMG is downloaded, it is essentially a Bootstrap. It's named Bootstrap. It's a Bootstrap installer, so to speak. And once that is downloaded, the victim will double-click it, mount the DMG. Once mounted, it will open up the Bootstrap installer macOS application, which I wrote and put in a bunch of malicious Python code that spawns these bind shells. Once we verify the bind shells have been created in our processes, I will start the check ports Automator job. That will start the, in the background, it'll give us some voice feedback, and then it will run the Python script and update us as a open port is encountered, as the process ID is correlated to it, and as the Python script terminates that process, which kills the bind shell. So I think let's get started and see how all that works. I'm just going to browse to searching for Bootstrap. Obviously just try the first one, most popular on Google. You can see the domain name is still getbootstrap.com, which is correct, but this is actually the attacker hosted website, but looks pretty legit, looks pretty professional. And then here's the link to download. Try Bootstrap. DMG is downloaded. Now we're going to run it. And then it automatically gets, the DMG is mounted, and here is our Bootstrap installer macOS application with all the malicious Python code written behind it. Double click it, run it. It says, hey, you download this from the internet. Are you sure you want to open it? This is pretty standard. This is not flagged by antivirus. As you can see, I'm running Sophos, and the Python code in here is pretty standard. It's just opening a TCP port, so it's not actually flagged as malicious, and it wouldn't be in the definitions of any antivirus, not just Sophos. And this prompt is pretty standard for any installer you download from the internet. So let's go ahead and open it. So we can close. All is well. Maybe the user didn't think it ran, but it is executing the malicious code as far as the attacker is concerned. So here we will grep looking for Python processes in our Python list. In our process list. So we can see here, these are the various ports that the bind shell has been, these are bind shells that have been opened. Here is the corresponding process ID to each bind shell. We will start this bash script which I wrote, and it monitors process ID or Python processes. So right here we can see the processes. The grep Python is just the it's what's written in the script. I didn't comment that out or omit that, but by the time the Automator job finishes, all we will see is the grep Python command, and that is essentially just searching through the process list looking for malicious Python processes. So let's go ahead and open up Automator or dictation. Once dictation is opened, we will execute the job. Check ports.
Checking for listening ports. Port 10,100 is open. Process 12,600 terminated. The scan will now continue. Port 10,200 is open. Process 12,669 was terminated. The scan will now continue. Port 11,100 is open. Process 12,670 was terminated. The scan will now continue. Port 11,999 is open. Process 12,671 was terminated. The scan will now continue. The port scan has completed. Finish checking for listening ports.
So as you can see, the Automator job completed, check ports job completed, and all we are left with is the grep statement looking for processes. You don't actually have to have this open. It was just helpful to see as each process was terminated. So as you can see, Sophos did not catch this malicious application, but a host intrusion prevention system like this Python script running in the background did, and it essentially stopped it and stopped the bind shells from running. You can automate this even further by just including it in a cron job and omitting the feedback, but it does kind of showcase a hot topic right now in technology, which is the voice control such as Alexa, Google, Siri, things like that. So as far as mitigations, what can you do to prevent this kind of stuff? Obviously, if you don't want to use this Python script, I'm going to create a blog post that goes into detail, detailing the code behind the Automator script, the Python script, even the kind of the listening port script in the background, which is right here. This is actually the script doing all of the port scanning and process termination. So if you do connect to a open Wi-Fi network, not password protected, let's say you're even in a trusted geographic location like Starbucks, McDonald's, you connect to that Wi-Fi network, assuming it's secure, because you would assume the company, restaurant, or institution would have the latest and greatest updated router, access point, device in place. If you do decide to connect to these open Wi-Fi networks, just be aware that there could be an attacker on the network sniffing traffic, looking for credentials, trying to send malicious payloads like we just saw. One way to kind of resolve these issues would be to use a VPN. So I do not recommend free VPNs. Usually you have just as many problems as 10 hackers on a legitimate network sniffing traffic. So what you need to do is find a reputable VPN service. In a blog post I did about a month ago on free Wi-Fi, at the end I listed I'm not going to tell you which VPN service I use, but I do use one, and it's ranked pretty highly on this link, and I'll be sure to include that link in this blog post as well. So what a VPN does is it tunnels your traffic. So you connect to this Starbucks open Wi-Fi network, so to speak, and then you start your VPN client on your phone, computer, it doesn't matter. So what happens at that point is your network traffic is tunneled through this VPN service. Now you're not secure by any means going through this tunnel. It's essentially just someone else's network traffic to sniff through. So hopefully these VPN companies are not doing that, and the link I'll provide kind of showcases who the best companies are and what services they provide, whether that be not selling your data, not even looking at your data and things like that, but you always have to take that by word. But either way, it is more secure than an open Wi-Fi network. And so once you're tunneling that traffic through, when I say your data is by no means secure, it's because your data is not necessarily encrypted. Things to watch out for is even if you're in this VPN tunnel, don't use sites without HTTPS enabled. So the reason this DNS spoof attack was possible was because this site did not have HTTPS enabled. So we can see the same DNS spoof attack attempted against a HTTPS enabled site. This domain name also has Bootstrap in the title. If we go to it though, we are actually taken to the legitimate bootstrapdocs.com site. And that is essentially because of the HTTPS enabled SSL certificate or TLS certificate on the site. I think that about covers it. I'll be sure to include any details I forgot to mention, and certainly go further into detail as far as the scripts behind all of this. Provide some links. Hopefully you enjoyed this. I'll try to do more videos like this as far as raising security awareness, as well as just showing you what's out there and anything new and cool I find and want to share with you guys. Thank you for listening, and see you next time.